Hi. So I'm doing this video to help you understand reflections about the y and x axis. So let's look at this. So let's say that these are my points. Let's say I have a very simple little graph. And these are just the points 1, 1, 2, 2, and 3, 3. There's getting put in space around it, okay? And I wanted to reflect this about the x-axis. That's the horizontal axis. Sometimes they call this a reflection about the x-axis or a vertical blip or but okay. So what would happen if I pick this up and I like flip it down, right? If I flip it down, then all 3 points are going to just go like here, here, and here, okay? I'm flipping it like this x-axis is a mirror. Then what new points result? Well, the horizontal position of each point does not change. It's still the same as far as left to right, right? So this, but all of the y coordinates become negative. So this is no longer 1, 1, it's 1, negative 1. And then this is no longer 2, 2, it's 2, negative 2. And then this last point would no longer be 3, 3, but it would be 3, negative 3. So what happens when we flip something about the x-axis is we actually change we take every original y coordinate and make that negative. So let me write that out. If I just take every y coordinate of my graph and I make every original y coordinate, opposite in sign, really. What I mean is opposite in sign. If it was negative, you make it positive. If it was positive, you make it negative, right? Okay. Takes every y coordinate and makes it the opposite of what it was, okay? Maybe it's better language. Or when you make something negative, making negative, it means to be positive, right? So, or better opposite in sign, right? Or I'm going to write negative because a negative of a negative would be positive. Makes it the negative of what it was originally, okay? Okay, so that means if I want to cause a reflection about the x-axis, we have to think about it like this. Let's say I have an original function, f of x equals x squared. Is this, am I changing, am I making the inputs, and the input is usually always your x value, and the output is usually your y or g of x or f of x value, function value. So am I making, when I make the y coordinates negative, is that an input that I'm making negative or an output that I'm making negative? Well, back to our old table, you plug in a y and it gives you, or plug in the x, it gives you a corresponding y value to that x value when we do, we do a little table for a function like f of x equals to x squared. Right. So they are taking, let's say, okay, I plug in 1 and that gives me 1. I plug in 2 and then get into that equation and it gives me 4. Okay. I plug in 3 and it gives me 9. If I was to flip this, I'm taking all of these y coordinates and making them negative. So I'm taking the outputs and making them negative. So So it's like the input already got plugged into the equation, it already got squared, and then we're making that answer negative. That's what we're doing when we do a reflection about the x-axis. We are making the outputs negative. Because y-coordinate is output. You know what I mean? Opposite of what it was. Well, how do I change this function to make the output negative? Well, if the function is squaring, then I put the negative on the outside of the square. So the resulting function, if I want to take this f of x equals x squared and flip it about the x-axis, I would make the output negative by putting a negative sign on the outside of the square. Okay, now notice I'm not doing negative x squared, because I'm saying take the square and then make whatever answer you get negative. Okay, so that's what the equation would look like if we wanted to flip this equation f of x equals x squared. If we wanted to flip it about the x-axis, we would write y equals negative x squared. Okay, now what if we wanted to flip something about the y-axis? So let's just look at what that would look like. Okay, reflection about the y-axis. So let's say that I have the same original 3 points. So 1, 1, 2, 2, and 3, 3. And the line that connects them, okay? But we're really focused on just these 3 points, okay? If I want to flip it like a reflection about the y-axis, then I would get these 3 points. They would all have the same y-coordinate because they have the same height, if you will, off, like this point here is the same height off of, I think that x-axis is the ground, you can think of it as the ground, right? So this is still the same y-coordinate here. It is 1, but then now it's on the other side of the x-axis, so it's negative 1, 1. And this one is the same height as this original point over here, so it's negative 2, 2. And then this last point is going to be, it's the same height as the original point, but it's just now on the left side of the graph, right? So it's negative 3, positive 3, okay? So now we can kind of look at what happened. I did have a 1, 1, 2, 2, positive 1, 1, positive 2, 2, and positive 2, 3. And then 1, 1 became negative 1, 1. 2, 2 became negative 2, 2. And 3, 3 became negative 3, 3, which means, what did we do? When I reflected out the y-axis, I take every x coordinate and make it negative. Okay, which means that if they're taking an x coordinate and I'm making it negative, am I making the input negative or the output negative? An x coordinate is input. So I'm making the input negative. That means the thing that we plug in for x itself is going to be negative. So we're going to end up plugging in negative x into this squared function. So it's going to result in put negative x here, right? That's what's the input. So my final output is going to just be, negative x parenthesis squared. So that's what our equation is going to look like. Y equals, or f of x equals, if you want to be happy and use this f of x notation, it's negative x squared. Okay, that is the equation that it would look like if we flipped this x squared function across the y-axis. It would look like negative x squared, and with the negative as being part of the base of that. And so there's a big difference here. If I have negative 3 squared, that would be negative 3 times by negative 3, which would be positive 9. Okay, if I'm working with this other equation, the first equation, if I do a negative x squared and I'm plugging in 3 for the x, then I would do, this means 3 times by 3 with a negative on the back, so it's negative 9. Okay, so there's this function is doing something different, right? So if I want to keep with this notation, like it's f of x. Well, I shouldn't really use f of x because these are new equations, really, right? This original function was f of x, and we'll call this like g of x and h of x, really, right? Because we reserve a letter for every different, but okay. So for reflection about the x-axis, we actually took every y coordinate and made it negative, which meant that I just, on the outside of the squared function, I put a negative sign. And then for reflection about the y-axis, I had to take every x coordinate and make it negative. So then that I had to, if I make every x coordinate negative, I'm making the input of the function negative. So what I put into the squared function was negative, and it resulted in this equation. All right, I hope you find this very valuable, and you can kind of check, you can kind of, you know, let me show you a picture of all 3 of them just to make sure that we did this right. All right, so unfortunately I didn't pick the best example for this, but here is your original function, f of x equals x squared. If I flip it about the, what did we say? We said this first equation with the negative on the outside flips it, we'll flip it about the x-axis. So there's your function. It's exactly what we thought. We changed the output value to be negative, and it flipped it across the x-axis. I think in my mind, when I think of these, I think when I make the output negative, it flips it vertically, you know, like from up to down, you know, like that's what I just kind of for me, my own thinking, like y coordinate negative, y axis. I'm just thinking vertical movement, right? Okay, and then we'll see that later with other functions, like when we add to the outputs values, then it's a vertical translation as well. So I think this is like a vertical flip. That's what I like to say this about. Kind of helps, makes it go without all the other shifts and translations that we see later. Okay, but let's see what happens. Okay, so I'm gonna take that one away. And then this one is when we flip about the y-axis, and this one's kind of weird. Let me show you. So right now our graph is this purple color, and when I click on this reflection about the y-axis, where I change the input to negative, they're actually, that graph lies right on top of the original purple graph. And it's because if you think about flipping it about the y-axis here, it's the same exact picture. So that's why we don't see a different picture. Just like now it was purple and now it's green. So I probably should have picked a different function that kind of, so you could see a visual more. It's unfortunate that these graphs actually lie right on top of each other, right? But I hope that you understood these vertical and I call them vertical reflections, and horizontal, like left and right reflections. That's what I prefer to call them. And so instead of saying reflection about the x-axis, I just say a vertical reflection. And then instead of reflection about the y-axis, I just say a horizontal reflection. If that, hopefully that I feel like that wording can kind of help you, like I said, with later on. Thanks. But anyways, I hope you found this very valuable. Have a great day. Bye.